Question 24. The function f of x equals the absolute value of x is transformed, and the equation of the new function is of the form y equals k times f of x plus b plus c, where k, b, and c are constants. The graph of the new function is shown. What are the values of k, b, and c? When the function is in the form y equals k times f of a times x plus b plus c, where x plus b is in its own set of brackets such that x is monic, we consider the dilations, then the reflections, and then the translations in that order for each dimension. Now, if x is not monic, factorize out the coefficient of x before considering the dilations, then the reflections, and then the translations. So for example, if we have f of 3x plus 1, the coefficient of x is 3, so x is not monic. We factorize out the 3 from the 3x and the 1, so it becomes f of 3 times x plus 1 over 3. Now you can consider the dilations, the reflections, and then the translations. In this particular question, this is not an issue since x is already monic. Now, starting with the original function, y equals absolute value of x, and the graph of that is shown here in red. There's a vertical dilation by factor 3, so it becomes the green curve. There's also a reflection in the x-axis. There's also a translation vertically and also horizontally, and that can be seen by tracking the vertex of the original curve and then looking at the transformed curve, or the vertex of the transformed curve. So considering the vertical dimension first, there's a vertical dilation by factor 3 and a vertical reflection, hence k equals -3. There's a vertical translation down by 1 unit, hence c equals -1. Now considering the horizontal dimension, there's no dilation or reflections. There's only a translation. So there's a horizontal translation left by 2 units, hence b equals 2.